side by side. You know I'll come running when you need. I'm coming. You know I'll come running. If you go to war, then I'm going with you. Pick up my sword, yeah, there's nothing I won't do. When you sound the alarm and the chaos is rising, leading the charge, yeah, I'm coming, I'm fighting. Swear on the breath that I breathe, I'll never retreat, yeah, I'll be your army. If you go to war, then I'm going with you. Pick up my sword, yeah, there's nothing I won't do. When you sound the alarms and the chaos is rising, leading the charge, I'm coming, I'm fighting. Swear on the breath that I breathe, I'll never retreat, yeah, I'll be your army.
So cliche, I see the sparks you throw my way. I know your name is written on everyone's mind. Your whole show is captivating me, but don't think that I can see right through that disguise. But when you got close to me, you had me falling so hard, baby, yeah, now I get it, you got heads turning, and you don't even try. Well, would you look at that, my glass is empty, how about I get another drink, baby,
Watch this.
baby. Okay, I get it, you got fire burning, right there in your eyes. So when you got this whole thing, I like the way you look at me. How about we just go with the flow? Now you know I feel it too. But I don't think this could be something that becomes a thing. Maybe just for tonight, then I'll be over you. But when you got close to me, you had me falling so hard, baby, yeah, now I get it, you got heads turning, and you don't even try. Well, would you look at that, my glass is empty, how about I get another drink, baby, okay, I get it, you got fire burning, right there in your eyes. Oh,
pair of jeans, a shirt or two. We didn't pack as if we weren't going back. It doesn't matter if it's true. I've got a feeling love will give us what we lack. The world is waiting up. The world is waiting half a step beyond our door. Yeah. And if it's not enough, I wanna see the stuff the world has got in store. I wanna take it all in, I'm falling. The cityscape by night, wanna catch in my photos. Where you go, every corner twice as bright. They'll be my treasures forever. When I can't hold you tight, I'll see the Stockholm lights. The Stockholm lights, the Stockholm lights. Tomorrow feels a year away, like the seconds, the beginning and the end. But if in time it's yesterday, your picture's gonna bring it home to me again. The world is waiting up. The world is waiting half a step beyond our door. And if it's not enough, I wanna see the stuff the world has got in store. I wanna take it all in, I'm falling. The cityscape by night, wanna catch in my photos. Where you go, every corner twice as bright. They'll be my treasures forever. When I can't hold you tight, I'll see the Stockholm lights. The Stockholm lights, the Stockholm lights. Got me trapped inside this spell. Now I feel it, now I feel it. Your demons drag me close to hell. I can feel it.
Hello everyone, we are back today for working on the x86 instruction decoder. So last time when we left off with it, we were just finishing up parsing out the SIB, or decoding the SIB byte. So that's what we got for this function, and I think it ended up taking basically a whole stream, mostly because we ended up writing a lot of tests, and there were a few tests that we were missing, and there were some bugs that we caught by writing those additional tests. So, you know, there's not a lot of code from this ultimately, but it's going to be useful. We're going to reuse this, and in fact, this whole chunk, or most of this chunk, whatever it is is going to end up probably being factored out into a decode mod RM byte, and 1 or 2 bytes really, because it might be followed by a SIB byte, or I guess we could also be including the displacement in that, and potentially an immediate. Probably we would be parsing the immediate after the mod RM. So yeah, we would have a displacement on the SIB byte or displacement on the mod RM byte. So anywhere from 1 byte to 6 bytes in the 32-bit mode that we're supporting right now would be parsed out from decode mod RM. So we'll probably end up moving that into its own. We might want to just do that refactor first, because I highly anticipate that when we start dealing with additional instructions, we will be wanting that anyways. So let me go ahead with that. So why is the instruction size automatically 2? I guess it's 1 for the opcode and then +1 for mod RM, and it gets added up potentially another 4 from that, or really another 5 in this case. So we could have a 7-byte instruction in this, and we probably have some tests that show that. Yeah, so here we've got a 7-byte instruction, pretty sure. But this is just mod RM, so that's interesting. Is it... Let's see. Oh no, this is multiple instructions. Do we have... Yeah, so we've got 7-byte instructions here, and each one of these lines is a single instruction, and we're just looping through a bunch of alternatives basically. So yeah, that's right now. We have stuff from just 2 bytes up through 7 bytes right now. Not that that's like a great metric, because stuff is all over the place, but there's a broad sense of the kind of range that we support. It can be useful. So let's pull out this code and figure out what those parameters are in a second. So we want definitely const uint8t for mod RM. Then we need uint8t pointer for ixns and the instruction itself. Okay, then we can say size t instruction size equals 1. So everything starts at 1. And we will go ahead and return instruction size. Okay, then we don't really need to care about instruction size modification from the SIB byte, because it's always going to be 1. If the SIB has a displacement, unfortunately the way that's encoded, we only know that from the mod RM byte itself, so we handle that right here. Yeah, so do we need W as well, I guess? Okay, where do we want to put that? Or that's a bool, I guess. I think that's the only one that we need. So then let's do inster size plus equals decode mod rm, pass in that mod rm byte that we already got. We will pass in w, and we'll pass in ixns plus 1 and the instruction itself. What have we done wrong? The address of the, no, I'm passing the instruction pointer. Yeah. Okay, so that should work. Let's build everything, and it fails. Okay. Cool. Kills a lot of stuff. So I'm doing something wrong here. Should I be maybe? Okay, I think. So I sort of changed around the implicit assumption around what IXNS is doing. Meowcat, can I ask you a question and don't get offense? I mean, probably you could say something that would offend me. I'm going to try to not take any offense at it, I guess. But feel free to ask the question. So then oops. Oh no, we do need to dereference it when we pass it into SIB because we just pass in the 1 byte. Okay. So the issue that was, oh, I missed that one again. I think what was causing these failures, and if it doesn't fix them, then we'll definitely go in and look at the actual assertion lines that failed. But I think the issue was just the way that this code was originally written. IXNS was pointing at the mod RM byte, and now that we are calling it, we are passing in a pointer to the byte that follows mod RM. So, yeah. And I mean, it's possible, I think, in a couple of these cases that is going to point to like the byte beyond the buffer, if that happens to be the last byte in the sequence of the instruction sequence. But as long as we aren't dereferencing it, that is actually not undefined behavior. I think you can have something that points one element beyond your array in legal C code. And as long as you don't dereference that thing, it's not undefined behavior. So in these couple of cases where mod RM is just 1 byte and nothing follows it, that should be fine. And then in the other cases, we're just going to have to assume that there's additional bytes. I'm not really writing this from the perspective of safety around what if you pass in a buffer that is not long enough. Mostly because we don't. Yeah, I mean, I could definitely make a thing that, have the decode function take in the length of the buffer, and then we can track that and pass that in through all these functions and double check that length as we go. But for right now, I'm not sort of worrying about that situation. So, okay, we still have failures though. Something I'm doing is wrong. So let's look at the test code. 207 is the first failure. So we are getting the wrong opcode. It's not an OR. Interesting. Are we returning the wrong instruction size? Yes, this needs to be 1 as well. Okay, cool. Because I was mentioning that earlier where instruction size starts at 2 because we were assuming a mod RM byte, but now that we've abstracted that out into its own function, we should just say it's 1 for the opcode that we are, and we will add on however many bytes are taken up by decoding mod RM in further elements. And this stuff is handling the immediate case separately, because right now we don't have any instruction. We don't support any instructions that have mod RM and an immediate. We'll have to get to that when we get to it, I guess. So okay, this passes all of our tests, which I feel like is sufficient. Like in terms of, I feel like if we're passing all these tests, then I've probably done the refactor properly. I'm probably not missing cases where I've broken it. So I'm gonna, oops. Okay, so okay. Now we get to think about additional instructions. So we can look at these opcode tables and see if there are instructions that we want to, that we'll find easy to handle, I guess. So I mean, ink might be relatively easy to handle. It's gonna have a 4, I guess, in the high byte. Have to see. So yeah, in the high nibble of the opcode byte, we could, if it's a 4, then we know that is a increment. Although there are, I guess, some rex prefixes. I'm not sure if I am misunderstanding how this is. What's it a link to? Something. Misunderstanding if this just means like, oh yeah, if you see this byte, it might also be a rex prefix, depending on what the following bytes are, or if there's some interaction between the increment EAX and having a rex with no dot whatever. But it feels like these are completely separate things. So if we're not dealing with anything 64-bit right now, we can just think of, if the opcode starts with has a high nibble of 4, then we're dealing with an increment. And can find dec. Also, I don't know if that's increment only with, say, i64. What does that link to? I see. So yeah, we can't do increment or decrement in these single byte versions with 64-bit mode because it's IC. So if you're in 64-bit mode, you just don't have this encoding of the increment instruction. Okay, that makes some sense. Where's decrement? Decrement is the other half of the bytes that start with 4 as the high nibble. So why don't we just go ahead and do those, and then I think we could even look at push and pop because they have the same structure with the 5s as well, like the whole row in this table. And so those might be simple things to add in. And yeah, I don't know, like start just picking and choosing other random ones. Because I think after those, we either get relatively complicated ones like the JCC stuff, which actually does cross the whole thing. So we could go for JCC after that, depending on what the operand encoding kind of stuff is. We'll have to look at that as well. We could do that, and then the move stuff seems like it might be a little more scattered. We've got some move stuff starting with A and the whole B row on this side of the table. And so the whole B row on from 0 to F, right? Yeah. Is moves, but then there's also some move stuff up here, and LEA is like randomly in there. And then on here, the move stuff is also in the A section. So I'm sort of looking for ones that are like organized in a way that makes parsing out the opcode instruction relatively straightforward. Just because I think it'll result in less code. And then as I get to the odds and ends, we will just have to deal with that when we can, I guess. So the thing I'm going to start with is increment. And now that we know those are the ones we want to deal with, we can come down here and find it in the table down here. So increment, the alternate encoding. Oh, I see. Well, that's it's interesting. They have a still single byte, but it is like FF or FE for I guess this is if you want to do the register and you're in 64-bit mode, this is the one that you use. And otherwise, yeah, so this is just doing the mod. Oh, I see, and it's got 3 bytes for the extended opcode bits. Okay. Might have to parse those out separately. Trying to see, so if we have full, like FF is the opcode byte, does that always then have some bits in the 3 bits inside of the mod RM byte? So these ones are not FF, but they are F something. I guess I'm trying to figure out which instructions have sort of these additional 3 bits. So these ones are FF. That was the increment that I was looking at, I guess. Same here. for these. Then this one is not, but it's also got the standard 0f multi-byte prefix, so we're going to ignore that because we're not doing multi-byte ones yet. And these ones start with F as well. So that's a category that we'll have to think about separately, I suppose. Yeah, but they do all seem to be sort of in a certain, except for some of these starting with F in our single bytes. Yeah, there's not as much rhyme or reason to them as I would like. There's these category. So I'm just trying to think forward to like when we deal with more opcodes in the opcode parsing, how do we sort out the ones where we need to look at the additional 3 bits in the mod RM? And further, how do we reuse the same mod RM function and modify it in a certain way to say ignore those, like don't put something into the instruction operand information for this piece, because otherwise that encodes a certain value of I guess reg. So it would be a certain register value to have all 3 ones here, or 110 or 100 or whatever it is. But these are just additional bits in the opcode itself. So they should be ignored when parsing the mod RM stuff. Okay. I don't know. I guess I'm going to be real flexible with it and just say I feel like dealing with that right now, rather than moving on to the increment instructions at this moment. So these couple of variants on compare and sub and all that are the ones that we don't actually have support for yet. The ones that have a mod RM and an immediate, rather than the one that only has immediate and always works with the A register. So let us start parsing those out, I guess. And those all start with 8, I believe. Immediate group 1. Interesting. Where is the grouping information up here? just search through and see what comes up. They don't have a media group, even though I could have sworn that was right here. Oh, they called it group, GRP. Okay, but that's the only place where it's mentioned. So what is, I guess it's note 1A. Is the 1A mentioned anywhere? Yeah. By group number. Okay. What? So this is 1A. What are these extensions about? Is that where it is like the additional 3 bits in the moder M byte? It's a group 1 instruction. Oh, okay. It's maybe it's mentioned in table 1A, but it's group 1 that we're talking about. Okay. Or I don't know what the 1A is about actually. Do they have a, like, where are the, okay. So group 1 has add as those, yeah, okay, this helps. So it's gonna be an opcode of 80, 81, 82, 83. We'll have to look the details in there, but they do tell us what the bits are, and these all happen to be the set of instructions that we are basically working to support right now. So, okay. Then we still got to figure out what the opcodes are. So these ones are, oh, I see, it's 80 through 83 because we could have the S and the W bits set, or the some of them might have a 1 bit in here. Or sorry, no. That, yeah, both of those being set is 3. Okay, so we are looking for I guess if it's an 8 in the high nibble of the opcode byte, and let's look at that table again. So we could also have a test or an exchange, and I'm curious how we would, I guess it's just because it's like if the low nibble is between 0 and 3. Yeah, okay. So that's relatively easy to test for in the opcode section. I honestly think that this approach that I was going for may not be worth doing. I don't know. I'm going to take out so these are the instructions that we want to support. Does that match up with the... I think so, because you can only encode 8 in that nibble. So, how do we want to parse this guy? So these we set the operand up here based on the opcode bytes. So we might as well do it down here as well. Where am I at? Okay, so in this case, if, what do we call it? Opcode L shifted by 2 is equal to 0. We need to then see, now this would be a place to get fancy with the opcode ordering. Just, I mean, I don't know if I want to be fancy with it right now. But in theory, what we could do is, like, since we know add is 0, then we could order them in this way and just add whatever the value of that portion of the mod RM byte is onto our thing. Did we order it that way already? ADC, SBB, and sub XOR compare. If we just do that, then we're good. Okay, I might as well use that, even though, you know, it's one of these sort of like hacky micro optimizations. Inster opcode is equal to, can we say opadd plus and so I have a function that gives us the mod RM byte, and we just want to say return. So it's going to be the, let's see, this is the high 2 bits, middle 3, and the low 3. So we're dealing with the middle 3 here. So mod RM, and how do we do it? Up here. Did and 38 and then shift over 3. We do return a value right now, don't we? What is this saying? How is that not returning a value? Oh, give me that. Now, does it let us actually do that addition? I guess so, because it is C, so it's happy to let us just treat the enum value as an integer. I don't know. Not-void function does not return a value. Do I need to cast this? No, that didn't seem to matter. So, what is your deal? I don't know. In that case, we'll set the instruction opcode, and then we will say return decode opcode basic. Think we want to say basic immediate, and you know what? Let's change basic to group 1, since that's how they seem to refer to it in the manual. And we will pass in okay, so we don't need the flags, right? Oh no, we do need the flags. But it's just going to be the low. Those low 3 bits, or low 2 bits rather. Okay, then we're basically gonna repeat this one. You know, let's go ahead and keep it. Do I want to write some tests first? Let's do a test for add. So immediate to register, so it's going to be reg. Let's say reg 32 immediate. If the register is 32, then I guess, yeah, we'll just put on the size of the immediate as well. Figure something out for that. And then we will do just going to decode one instruction right now, I think. And it's going to be 0x8 1. What is the S again? I feel like I knew this last week and I have since forgotten. S is to sign extend. So I guess we just didn't have S in any of these previous ones. I see. The 1 bit was referring to whether we were swapping, so that's more like the direction bit. So in this case it's whether to sign extend. I don't know how to represent that. I guess we'll just do it when we are setting the operand value. Like we can just know that ahead of time. And that's only on 8 bits. So, okay, so we'll just do no sign extend on this one. And if we're doing an add, so we're going to do this one. We want it to be, let's see, 1 1, and then so we do all zeros, then we're looking at is that 192? Or in the upper register, that is C, I think. Yeah. Okay. Then C0 will give us EAX as the register, and our immediate can be just do it real simple like. So now if we say Citus info 32 81 C0 01 02 03 04, that is add this immediate value to EAX. So what we're going to expect is okay. Oh, so now my typing is off. So that'll be our opcode, and then operand 1, the register, I guess we could say I want to do that, that's fine. Operand type should be OT register and op1.type, and then register So that's what we would expect. The immediate is always a uint, but why can't we? I guess it doesn't matter. In this case, maybe. No? We always gotta force it, I guess? Okay. What are we doing wrong here? We're not using instruction size, right? So we also want to The instruction size should be 6. Why you gotta be like that? Okay. Then let's do another one. This time with memory. So we'll do maybe a compare with how did we refer to it up here for the SIB stuff? Just with the displacement amount or mem and displacement? I see. Then I guess we can do memory and displacement 32. So in that case, what does the compare look like? So we're gonna have all those bits are set, and the mod value is going to determine, we want the 32-bit displacement, which I think is probably going to be 1, 0. So we're looking at 1, 0. 1, 0, 1, 1. Which is what? B? Yeah. B, and then what is the register that we want to use? Say EBX, so that's probably going to be 001. So we'll have 1001, which is 9. So B9. Linus didn't make Linux. Hey, how's it going? Welcome back. Working on the instruction decoder right now. Trying to get this category of variety of like compare instructions working. When you say it's that early, do you mean like in the process of writing the decoder? In which case, yeah, I've only been working on this on stream, so it's been going pretty slowly because I'm only streaming this stuff twice a week, so we're looking at maybe 6 hours a week. And I don't know, I'm just not the fastest coder in the world. So, oh, the time of day. Well, it's 8 a.m. in Seattle, but this is my local time right now, so it's about 10 p.m. So it's actually, you know, I'm almost always streaming at the end of the day, for me. But I either stream very early in the morning, which is almost like very late Seattle time, or just US time in general, or I'm streaming quite late in the evening for me, which is morning for people. I think this time is actually worse for people. I've definitely noticed fewer people watching the stream since I switched over to this schedule, but it works a little better for me right now. Not quite vacation. I'm here in Thailand for this year. I've sort of got a education visa, so I'm taking these like self-defense courses, which it's been difficult because we've had to do it over Zoom because of there's pretty significant like quarantine measures still in place here, even though everything has been going really well. The coronavirus situation has been incredibly under control for the past like 2 months at least. But they still have not decided to open up the schools again. So I'm sort of doing that, but mostly it's intended to give me time to work on stuff like this so that when I go back to the US, I will hopefully feel a little more confident to apply to the kinds of jobs that I want to go to, that are more in the maybe infosec hacking category of stuff, the stuff we talked about yesterday, which I just don't have that much experience with, and I was not getting around to getting a job doing it when I was in the US the last time, so I decided to take some of the last of my savings and see if I could spend a year here where it's a lot cheaper to live and just do this stuff. It's been working out all right so far. I've been working harder than I would like on, not necessarily on stream, but just in general, and probably not taking as much time to just enjoy the fact that Thailand is really nice. And there's, all kinds of interesting, weird stuff to see, and I'm mostly like go outside to go to the mall to get weird Thai food. I say weird, but it's just new to me. But I should be going to more vacation-y kinds of stuff. Yeah, exactly. Lots of places to visit. So I should be taking it a little more vacation style. But I also know that I don't know, I find it difficult to relax. My brain doesn't necessarily want to turn off. So maybe I'll go, I'll say, okay, let me go see the elephants, which I think might not be a thing anymore, because what I heard is they all had to go back to their villages, the people that run the elephant areas, because they didn't have any customers, because they cut off all the tourism, and so they needed to go back to the villages where they were living and try to make money that way. And obviously the elephants go with them. So I don't know if that's an opportunity, but I can easily see myself doing that, or going to some temples or other, touristy kinds of things. And I'm still in my head, thinking about this, thinking about, if I did that with my code for the register stuff, or, some hacking thing, I wish I knew how to just turn my brain off better. And because then I could go to those things and really be present in the moment, enjoying them. But thus far, I've had trouble with that. When I was working, it was the same kind of thing. I would just be so focused on the work stuff, and then I would say, okay, I'm going to take a week vacation, and I will go to, if you work in software, you get paid well enough that it's like, let me go to Hawaii for this week. And, my brain is just not I try to be on the beach and can't deal with it for whatever reason. My brain is going nuts, even though I'm just trying to enjoy sitting on the beach. Yeah, I think if I can just get a book or something, and then a fiction book, and I can get sort of wrapped up into that, and it's an avenue to being distracted from stuff. That's always a good plan. I just have had a lot of I think, it seems like the perfect kind of thing to do when you're at the beach and you're just enjoying being outside and it's sunny and you can smell the water and the sand and everything that's going on, and it's nice. Yeah, I think I just I need to be able to figure out that thing to trick my brain into not going into you're wasting your time. You have no time to do this and that and the other thing, anxiety or whatever. Because I will just get swept up into that for sure. Okay, so this should be mod RM, and it's going to have a displacement of 32. So let's do 0A, 0A, 0, or let's just do a simple displacement, right? 0A. Okay. So this displacement should just be 10. Yeah, I get the exact same anxiousness. Like, I mean, I will get that anxiousness even when I am not taking a significant break, when I am just trying to watch some television or YouTube or whatever. There's this low level, like, oh, you don't have time to do this. Right. And it's not actually a useful mental pattern. Because as you say, it kind of is wasting time thinking about the fact that you're wasting time, or just being anxious about stuff when being anxious doesn't impact anything. There's like a sort of hippie Eastern philosophy guy who was big for a long time. What is his name? I don't remember his name right now, but he was one of those, like, oh, you like, reality isn't, it's not real, it's all in your head kind of philosophy kind of thing. And there's a song that's in one of my playlists where it's got like a quote from him, and or a bunch of quotes from him, and one bit where he's at the end of what he's saying is like, no amount of anxiety has any impact on what will or won't happen, basically. And it's like, yeah, that is absolutely true, but also I don't necessarily feel like I have control over how much anxiety I have. Maybe I have some control over being anxious about being anxious. I don't know. I wonder if that's like an infinitely nestable kind of thing. Can you be anxious about being anxious about being anxious? Probably. I don't know that I've achieved that level yet, but I'm definitely anxious about being anxious sometimes. So it's just so much fun. Okay, so B9 is going to give us a mod RM for operand 1 with a register of EBX, pretty sure, and a displacement int32t displacement of 10. Let's just do 0a. op1.modrm.displacement. And then the immediate is still going to be the same immediate. We'll just leave that. So let's double check these bytes before I commit to that. B9 0a 00. Okay, so compare dword pointer ECX plus a, and then that displacement. So why is it ECX for B9? Oh, because it goes A, C, D, A, C, D, B, I think. That was always a confusing one. I don't know why B was organized in that fashion. Is it under here? Yeah. Right. A, C, D, B. Yeah. Okay. So we want register ECX. Okay, that's a pretty good set of stuff. We could definitely do more varieties of the mod RM byte, and maybe we should do 32, or sorry, an 8-byte one. And make this one let's do XOR. Oh, and this needs to say operand compare, and the size needs to be, is that 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. Okay. And so for this one, we have an XOR, and it's going to be memory no disp. Do I know any web languages like JavaScript or PHP? Yeah. I haven't used PHP much in a long time. I mean, I can sort of muddle through if I had to read PHP for, I don't know, some sort of kind of hacking thing. It sure seems like a lot of those challenges and stuff focus on sites that are running PHP for whatever reason, even though it feels like that has become less omnipresent over the years. Like, I would say the percentage of sites using PHP outside of maybe Facebook, and they're doing their darndest to not use it at all, has just been steadily trending down, but it still seems like a real big item in the category of like practice pen testing stuff. And so yeah, PHP is like what I started off with when doing web server side programming as like a middle school kid, back in the day in the early 2000s. And I did actually work on a relatively sizable PHP project. The website for the game that I worked on was a big PHP site, and I think the developer that originally created it was somebody that worked as was like part of the core PHP team, so he knew it really well, and it was like a very object-oriented, structured kind of thing, a lot more advanced than these sort of like small individual script kind of things. Like, it was basically like if you went and did PHP with Symfony or whatever the like big web frameworks that are in PHP, whatever they are these days, where it's really well structured and you've got like one endpoint that calls into all the other stuff rather than everything being a separate file that Apache runs. Like, that sort of like, it's just a different structure to how PHP was traditionally done. I think, you know, what he built was sort of like an early version of that, just some thing that he came up with. So I've definitely seen the more advanced kind of PHP stuff as well, but I don't really use it ever. And then JavaScript I have a lot more experience with. We taught it at the coding boot camp where I worked, and we used Ruby on the server side for that. And so I've done a lot of JavaScript, through, you know, basic stuff up through the more recent versions of it with ES 2015 and later, and done like through, you know, when it was all jQuery, and then real small frameworks like Backbone and React as well. So pretty, like, I guess realistically speaking, my broad experience with web stuff is like at least as large as on the more like you know, machine oriented kind of stuff, like native code stuff like C and C++. You want to get good at web stuff? Awesome. Yeah, JavaScript is definitely the thing to focus on, or what I would suggest maybe is also TypeScript. I've done some stuff with TypeScript, and it is I like it quite a bit in comparison to JavaScript. I think it just has some niceties, and then once you sort of wrap your head around the typing system, it's a really fun typing system. Turns out, like, it's real flexible because it's very like structural typing, I think is the term. So a thing is a type if it has the pieces that type has, more like, so to speak, which gives you just a ton of flexibility compared to the older typed languages like a Java or C#. So if you want to get into JavaScript and you know, you sort of learned some of the basics of JavaScript, I would say also check out TypeScript and see if that feels nice to you. It just feels like a much more intentional language, whereas JavaScript is obviously something that is grown out of a rudimentary kind of thing and has this resulting design of a lot of stuff is just like accumulated on it over time. And so they're a little hemmed in on certain things. But I'm glad that you got some use out of the assembly site. What was the other? I had some thought earlier where I was like, oh, I wish I had mentioned that when you were asking about assembly. So when you're analyzing stuff, one thing to maybe do is to start with like, just see if you can track the control flow. So if you're doing that exercise that you mentioned that you wanted to do, where you write a little bit of C code or something and compile it and then look at it as disassembly, if you get a decent disassembler such as Ghidra, or, well, Ghidra's maybe not the one to go for with what I'm talking about, even though it's a good one to use. Because it's mainly focused around the decompiler, so you won't have the graph view kind of thing, because it'll just decompile to C for you anyways. A login script, is there any good ones for free? Like a good disassembler tool? Radar is the one that I was using yesterday on the stream, and it's decent. If you get the cutter sort of interface for it, so there is a GUI tool for it called Cutter, and it really is just a front end to the, oh, this is not even the main page, I think. This is the main one, cutter.re. It'll take the radar stuff and it'll display the control flow graph and a nice GUI that you can sort of browse around and all that. But it also, you can enter the same exact commands that you would enter to radar. And if you want to use it for larger stuff, it also integrates with the decompiler from Ghidra. I assume you have to also install Ghidra to have that accessible, but this is what I would suggest starting with for free on Linux. And so what you can do, what I would suggest is like compile a little bit of code. You know what it looks like in C, and then just start by looking at the control flow graph, and which is this thing here. I don't know if they have better examples of it. Just sort of generally this kind of thing where it's like what you have, each of these rectangles is what's called a basic block, which is a chunk of assembly instructions that has no jumps or calls to other functions. I guess technically in the way they have this graph, the blocks are only based around the jumping, but then you have the lines telling you which other instructions it jumps to, because technically the assembly is in one long linear sequence and you are just jumping. So it's like starting here and going straight across to here, and you would jump back and forth within that same sequence in order to achieve like things like if statements and other control flow like loops. But when you're just trying to understand, hey, you know, what is the structure of this code, it's much nicer to throw it into a 2D view where you can have this graph and you would have a line that maybe comes out of here and goes back up to here if it's a loop kind of thing. And you would see, you know, they have a special looking kind of line to represent a loop that goes back, and obviously the arrow points on this side and comes out of here. So you can start to see how the instructions will operate and how you get to this jump instruction, which might be an unconditional jump, and that's going to be a blue line on this graph. So you can see the jump is unconditional in both of these cases, and they apparently jump to the same spot. But then if you have a jump not equals or some other conditional jump, you'll have two lines coming out because they might go to two different places. Or like the next instruction could be one of two different instructions based on the result of that conditional comparison, basically. And so even though you might not understand what all the details of the instructions inside of the rectangles are, one thing you can start with is just like, okay, let me get a handle on, if I write a loop in C, what does that start to look like in this control flow graph? And then that might, it also breaks up stuff a little bit, so you can see, okay, here's a chunk that seems to be the inside of the loop, because we do it and then we might jump all the way back to the beginning of that chunk. And then you can start to map what those pieces are to the bits that you wrote inside of the loop, for example. So that's just another tip that I have, is like maybe start with the overall structure rather than the details of the instructions. And then keep in mind all the memory stuff when you start to try to understand the instructions. How to install it? I don't know. I actually haven't used it because I use something called Binary Ninja, which is another. Does it have a clear guide on GitHub? I would guess so. I mean, they're really trying their best to make this a very easy to get started thing. I guess you could just click download on there, but you might, if you're running like Ubuntu or whatever, look under apt. Or you said you were running Arch, right? So I'm sure it's in Pacman. Or, oh no, I don't have it installed. Yeah, so you can install Radar 2-Cutter, and that'll give you the Qt thing. It's not even an R, right? Like, yeah, I use Yay as well, but this is like an official package, so you don't even need it. So yeah, they are doing their best to make it as accessible as possible. So I don't think you'd have a difficult time getting it installed, and then go from there. And then again, you can also use their like integrated Ghidra decompiler. The decompilation results are not like perfect, and so depending on your level of experience, it actually might be more confusing. I don't know. But this is like a better understanding of like how, so this is the linear view of the instructions are just one after the other, and they give you these little lines to tell you, oh, this is looping back up to here, and then it'll come down here and it might loop back up again, and this one might be a jump to just skip the loop entirely, so like an if statement that says, oh, if we don't have that value, then we'll just skip past the loop or whatever. And I guess you can see this function also represents these set of bytes in the hexadecimal of the file or in memory. And this is then the actual like control flow graph view. So you get a bunch of different ways to look at the same data, which can be handy, because it is kind of a advanced data structure, just the structure of the code itself. Okay, so what do we want? We wanted memory, no displacement, an 8-byte immediate, and sign. And I think since it's yeah, so then we want no, we just want 2, because yeah, then no displacement and an 8-byte immediate. Okay, and it's an XOR, so this is going to be a 3-byte instruction. Let's see what the XOR is. We want this one. S is on, W is off. And so we have no displacement is going to be all zeros. So 0, 0, 1, 1. Going to have 3 in the upper nibble. And then 1. And let's do 0, 1, 0. So 1, 0, 1, 0. Or wait. No. 0, 1. 0, 0, 1, 0. So just 2. And I think this is going to then be a mod RM in the first slot with, what did we say it was? 0, 1, 0 for the RM is DX. And a 0 for the displacement. We'll have 1 as the immediate. And if we want it sign extended, then we want to actually have the high bit set. So we want, let's see, if we do 9 there, then that's, yeah. So that's 1 byte, 2, or does it need to be, no, it's going to be F. 1, 1, 1, 2, 3, and then the low byte is it's just still 9, 1. Could be wrong on that front. All right, let's give it a shot in Zydus info. 82, 32, 91. XOR byte pointer of EDX with no displacement, and then 91. Okay. But if we, instead of that, do 0, it's the same thing. So, am I on a laptop? No, I'm on a desktop right now. Is 9, 1... 9, 1 should be a negative number. Pretty sure. So if we want to sign extend that, oh no, it was written down here, wasn't it? Signifies sign extension of an immediate field. So if it's 8-bit immediate data, it is sign extend to fill 16 or 32-bit destination. what happens if we do, right, if we do 3. Oh, so it needs to be W is on. So you got a gaming laptop running Arch. Yeah, I am never really trusting of laptop batteries. Although if you're running Linux, one of the things that I would be cognizant of is that, especially with Arch, because they don't have anything on there by default, you might want to look up in the Arch wiki maybe just laptop. I think they will probably have, yeah, power management stuff. So you might have to add additional features and like install other programs and configure them in order to be able to tell the hardware to do things like lower the CPU and GPU usage. So a lot of what goes on to make the battery in a laptop last a while is minimizing the power usage by sort of just turning down the CPU and the GPU and other components whenever possible. But some of that is controlled in software, and it's sort of, it works perfectly on a Mac because they have all the, and also the screen. I mean, the screen is a big part of the power usage by a long shot. So, if you're using Windows or you're using Mac, then those things have already been configured by either the hardware vendor or, the hardware vendor, who also might be the operating system vendor, depending on the model of laptop that you have. And so people that know how to configure those things or have written the software to properly control those pieces of hardware have done it. But if you've installed Arch, that may be something that's left up to you. And I feel like I've had similar things with my laptop, which is running Arch. It's not a gaming laptop by any measure, but it is sort of a beefy Lenovo. And it tends to get real hot. I don't use it on my actual, I don't use it on my lap because it gets so hot, which I think might be because I added a, one of those M2 SSDs, sort of aftermarket. And I think it's just, that thing gets real hot no matter what. But just something to live with, I guess. I much prefer desktops, even though it does keep me sort of stuck in a certain location. So I will look up the laptop page and just see if there's any additional stuff that you can do. Okay, so it looks like if you have the W bit on and the S bit on, that's when it does the sign extend. And I just am misreading how this works. Because I would think that the W bit being on means that we are, I guess if you have W and S, then that means you have an actual 8-bit value, which is sign extended to the size of the operand. Yeah, okay. So that's good to keep in mind. So then if we do 8.2, we're turning off that S bit. It should just say EDX and 9.1. Yeah. So what we want is EDX and all Fs 9.1. Okay, so that's got to be 8.3 instead of 8.2. Okay. Then that is fine, right? 833291. Okay. So I think this is a decent set of tests for what we're about to write. And if we run the tests, those don't even run right now. Because we need to call this immediate. Okay, so those last three tests that I just wrote are failing, so that's expected. Trying to make a decoder, yeah, basically something that goes and takes a sequence of the actual instruction bytes, the machine code, and then brings it back to it's not a decoder in the sense that it will, it's not like a disassembler, so it's not going to print out the assembly instructions. It's sort of like the entry element to a disassembler. So it generates a instruction data structure which has pieces in it like the operands that are being used. And so then you might write another program that takes a sequence of these instruction types and renders those into text, much like this part. So I've sort of got I'm working on the part that kind of does this stuff, although granted with maybe less detail, but ultimately should have most of these concepts in it. It's not going to have stuff like action and stuff. I should, perhaps look through the implementation for this to see what other kinds of information we can include in the instruction structure, but right now I'm just doing a very basic one. So it basically just has all the pieces that would be necessary to be able to print this out if somebody wrote a program that then turned it into text, basically. But nobody has written that program, and I haven't written that program either, so it doesn't do that yet. But it does turn these set of bytes into instruction information, like, it's a compare instruction that's got a operand 1 with an ECX memory reference and a displacement kind of thing. So that's, I don't know. The main reason was I wanted to understand how the instructions are encoded a lot better, and I have certainly learned a lot more just by going through this process. So it's already working for that purpose. Okay, so we know that we don't need that, and instead of D, it is S. So we're not going to have the if statement about the immediate, but also we're going to have this stuff later on, and we're not going to have okay. So yeah, we'll have to deal with that in a second. Oh, that's what we can do. I'm going to take out that comment about supporting 16-bit because I am not going to bother with it right now. Then, all right. So for mod RM, okay, how do we want to deal with this? It's already like an ugly large switch case. And we're going to have more conditionals in it, it seems like. All right, so how long is that? So we're going to pass in another Boolean, which is whether or not the reg section is a opcode extension element. Okay, that's the only place that we're dealing with operand 1 there. So we will simply not handle it. That's a what? Okay. We won't do anything with it if reg opcode is set. Then here we want to say false. Here we will say true. Okay. So if that is true, then we need to handle what operand 1 is. Operand 1. So W is, yeah, let me deal with operand 1 in a second. If W is set, okay, that means W is set, and then S is also set. Then okay. So if W is not set, then we've got an 8-bit immediate that is also not sign extended. If W is set and S is set, then we've got an 8-bit immediate which is sign extended. And then lastly, if W is set but S is not set, then we've got a 8-bit or a 32-bit immediate, which doesn't need to be sign extended since it's 32 bits. Doesn't need to be extended at all. All right, now dealing with instruction operand 1. Is there anything actually that we need to do after decoding operand 1? Oh, but this is setting operand 2 stuff. So, yeah. We need to do the swap. Okay, so first we use modrm to decode. We skip instruction 1, and you know what? I'm not even going to bother. I think we can get away with not having that extra parameter. And we will set operand 1, but we will just reset it to what we need later. So just to be clear, when we call modrm here, it's going to set operand 1 to be a register. Are you using a documentation to write all that C code? Yeah, I'm basically just working from this document, which is we can just go all the way to the top. The Intel Software Developers Manual. This is volume 2, which is the instruction set reference, and it has all the details of how things are encoded. It talks about how certain bytes are encoded. So if you have a byte that's 22, it means it's got this as the register and stuff. Yeah, it's very long, and I mean this one is pretty long. I guess it's 2,300 pages, and then there's 2 other volumes which deal with different stuff. There's stuff that just talks about the hardware, like CPU architecture, and there's stuff that talks about how to write like an operating system that uses the x86. So it has all these details that are important for like understanding the virtual memory system and how to do interrupts and all that. So there's a lot of stuff to learn, but this is the one that's most specific to what I'm trying to understand. Most of the pages in this, though, are like details of how the instructions work, and the code that I'm writing doesn't really care how the instructions work. I'm just caring how they are represented as bytes. But if you were writing a simulator, or if you needed to understand that stuff in order to do analysis for like static analysis for a disassembler or decompiler and all that, then the details of how all those instructions work is also necessary to know in order to be able to accurately represent them in your algorithms. Yeah, so you're getting the gist of it with the registers, where in a sense there's basically an A register, right? And it could have an AL or an AH, which they encode over here, that are the high or the low byte of the AX 16-bit version of the register, and then there's the EAX 32-bit, and they don't talk about it in here because this portion of encoding doesn't get used at all for the 64-bit register or instructions, but it could also be RAX for the full 64-byte or 64-bit rather. So yeah, it's using the same register. So if you set a value into RAX and then read EAX, you're reading the low 32 bits out of that same register. So that's important to know. Yeah, that's a key understanding that really mostly applies to this particular architecture. I don't think if you learned ARM or RISC-V or MIPS or whatever the other instruction set architectures are, I don't think they would have a mechanic like that at all. It's really a historical kind of legacy thing, as the same processor instruction set has been upgraded from the 8-bit days in the very early 80s through 16-bit into the early 90s when it switched to 32-bit, and then like 2007 or whatever switched to 64-bit. Nice. Yeah, that's awesome. I mean, there's a lot of resources out there, so it's really, if you can find something that sort of makes sense to you, then, you know, hone in on that one for sure. And that's one of the nice things is, like, at this point there's a lot of options. It's a good and bad thing, because you can be stuck on the, like, oh, how do I pick between these? But if you find one that doesn't seem to work for you, then, you know, you can just sort of set it aside and look at another one and see if you find, like, and keep searching until you find one that seems to make more sense to you. And, you know, additionally, just looking at a bunch of varieties of it, you sort of have a unconscious buildup of understanding. So maybe if you look at this series of videos and it doesn't seem to make sense, and then you go look at the next series of videos and it makes more sense, like, there could just be an aspect of, oh, you're seeing it over and over again and it starts to sort of coalesce into an understanding, which is certainly how I come to understand a lot of things. It doesn't make sense to me at first, and I don't know why it doesn't make sense, and then slowly it makes sense, and I don't know why it started to make sense. But, you know, there's not too many things that I read it and it's like, it all instantly makes sense. Certainly this stuff, like the encoding, makes a lot more sense to me than when I started on it 2 weeks ago or whatever. There's still parts of it that are definitely like a mystery, and there are parts of it that may not be something that will make sense ever, but that's fine. Okay. So yeah, so we get the mod RM stuff into operand 2, and then we want to swap that into operand 1, and here we will set operand 2 as an immediate. So actually, let me not do that. We got to do oh yeah, we want to set it to 0. Wait, what? It said string header? Wouldn't it be, it's not in standard lib? No, it's in string. Okay, okay. So just for safety's sake, rather than copy the old value of instruction, we are mem setting the whole thing to 0 and then setting the info that we need on it. All right. You know, we're getting somewhere, I think, because these failures are different. So some stuff is being set. 409. That immediate is not correct, huh? We need to add 1 for the mod RM bytes. So I'm setting instruction size -1 because decode mod RM might be more than 1 byte. And we got 1 that's for the opcode itself. And we don't care about that, I think, since we're already passing in, yeah. Okay, that fixed one of them. So as we add to instruction size, we need to pass over that many bytes -1 in order to start off getting the value for the immediate. So let's look at 419, just the opcode for comparison. It's not a comparison op. Are we not setting this properly? That fixed something, and that is weird to me. That's 56. Why? Why is it doing it this way? Oh, it's, yeah, okay. That makes sense. I had it as hexadecimal here. Let's just do it that way to be as obvious as possible which bits we're masking off. So we're masking off those 3 bits in the middle and then shifting over to get rid of the 3 low bits. So, okay. We'll do the same thing in here when we want to get the opcode extension value. And okay, so now we've got 1 failure left, 449. So this immediate, so this is the one that I feel like I am just not understanding it properly. So what I thought we would be doing is calculating the location where the immediate exists, and we're going to read it as a single byte. And since IXNS instructions is already a uint8t pointer, then this is going to be referencing a single byte. So then we'll dereference that, and we'll get the single byte, and then we will cast it to an int32t, which should sign extend that value. I guess let's look in Godbolt and see what I am misunderstanding here. So int types.h, and if we want a int32t foo const uint8t pointer I, then we want to say return int32t of I plus 1. Oops, not in Vim. Okay, so this moves and 0 extends. So why is it 0 extending? Do I then need to cast this? Yeah, okay. I see. So if we're taking the uint and upgrading it to an int32, it's going to 0 extend it because the whole uint space for an 8-bit can fit in the 32-bit int. Okay, that makes sense. Cool, so that passes all of our tests. So now we have every, why does it persist with this error? All right, I don't know, something in Emacs is broken. So this goes ahead and means that we now support all of the varieties of compare and all of the varieties of AND, OR, XOR, ADC, the group 1 instructions basically. So now, why don't we look at other groups? It's interesting, 1A just has pop. Or there's some other interesting groups. No, I think I'm going to go back to the plan of let us start trying to support some of these oh, that's interesting. It's also pause. Some of these like block wide instructions. So increment and decrement are the ones to start with, and then we can also do exchange, which happens to have the same instruction as NOP in this side, and that's fine. This is the exchange with AX. Yeah, might as well get started supporting those. So those are pretty straightforward instructions. Let's look at ink. At least for this variety, the middle one is the one that we are going to support for right now. And we'll have to worry about these other two varieties in a minute, I guess. So yeah, we're in this situation. And it's really pretty straightforward. What do we have for this stuff? So we're missing like op inc, op dec. Then we gotta throw those in here. Even though we aren't actually using this debug function anymore, or not at the moment. Can always apply it later. But we should probably fill out stuff that knows how to print out the operands and all that. What is this little red tick about? I don't know. Apologies if you can hear that. Alright, I'm gonna just commit this stuff. Alright. Then down here we have if opcode L and that's what we can do. So inc has a 0 here, and I believe dec has a 1 there. So I'm going to say inster opcode equals op inc plus opcode L and what? An 8 shifted over 3. Okay, then inster operand 1 dot type is equal to op register, or sorry, OT register for operand type. And that's interesting. So let's see what Zydus says if we do what is this, 4 and 8. So that does full register. So I guess it's just whatever whatever mode that you're in. So I'm gonna do opcode L and 7. W is true and size 32. Okay, and I should have wrote these tests first. So it's going to be 4 and 4 0. 4 1. We want to we'll just hard code all of them. What is wrong here? Oh, it's just not used. Okay. Then output, and we want to copy the loop code, I guess. So we don't care about the scale, that's not a thing in these instructions. We will memset the output, and then we will run this, and we'll say cursor plus equals instruction size. And then we're going to assert the instruction size, and the size t is just 1, because all of these should be a single byte instruction. And we'll assert the operand type, or sorry, opcode of op inc for output dot opcode. Okay. I have an idea for something that I should add to the test that will fail because I didn't write it when I was writing the code. Operand type. OT register is output dot operand 1 dot type. Shit. This is really hacky, but that's what I'm gonna do. Cool. Yeah, I'm probably gonna go for another 45 minutes or so, I think. Oh, thanks for adding me on Discord. I'll check it out after the stream. So if we're at EAX, then EBX is +4 and ECX is +4, so reg. Okay, and then all right, that should be enough to support all the possible registers with inc. We'll do the same for dec. And then these are going to be 8, 9, A, B, E D C. Okay. So operand type. Is that it? 463? No, the size. We didn't set the size. Okay. It's good to know. Okay, now it's probably the register is not right. So on the second go round, well, I guess it's fine because so the OT none is 0, and since we're mem setting it to 0, that's all good. Okay. So on the second go round, we or maybe not the. Let's see. EAX is 4. So yeah, on the second thing we expected EBX. Need to set these down here. And unfortunately, now my numbers are all off. Can we just say oops. Okay, so now it's EAX, ECX, EDX, EBX, which is actually the order that those operands are in the encoding. Okay, and now they all pass. Hey, that's nice. That was a pretty quick. Let's see what we did for this. We just added a little bit into the actual decoder because these are very simple instructions decoding wise. And then we added the operand types, or the opcode types rather. Reorganized these, so I should do that as a separate commit. Added those cases and then added our tests. Okay. Oh, I shouldn't have added everything first. No, yes. I don't know if that's too long, but I'll live with it. Okay. I guess we might as well start trying to support these guys. I imagine the it'll become more complicated as we start needing to involve other ones. But to begin with, yeah, let's do it. What is it? It's still never... What is memory? I think that's just not a thing, because I think that's covered by mod RM. But we definitely do use immediate. I don't understand why it thinks we don't use immediate, or some of these other ones. It's such a weird thing. Right? Okay. We definitely don't need memory. Yeah, so I think I expected, oh, we could just have a operand that represents a memory address, but really all of our memory accesses are a register with a displacement. Could be no register at all and just have a displacement, but it's a, we need it as the mod RM structure. There's no just straight up memory. There could be, but that's such a one-off case that we might as well just include it in here and set the register to reg none. So, okay. We want to support inc and dec other varieties, so that's down here. If opcode L and I'm going to just remove them from the list here. So we're going to start off by anding this chunk. And I guess we also need to yeah. What is it? Opcode extension of so we don't need that extra equal to kind of ugly, but there you have it. Oh no, we do need that one. Okay, need it for over here. So so we're already in, the high byte is all 4 ones. So we're in that situation. Then we check, are these 3 1s? And then we check, are these 2 zeros? Because then we're either a 0 for ink or a 1 for deck. Because I think if we look at F, there's probably other stuff in this portion where we're at F or E. So, let's see, we're at F. Group 4 and group 5. Yeah. In the case of FF at least, these instructions can be encoded with these bits in the opcode extension. So we can't assume it's ink or deck. But maybe we should just split this up for simplicity's sake. Okay, then we want oh, I broke too early. Okay. Or we could do a switch. How do we want to do that then? Yeah, okay. So the call will have a 0, 1, and it's near or far, and then the jump will have a 1, 0. And push. It's going to be in this last case. There's only one push, but that's fine. All right. So, do we want to oh, and these are all in group 5. So let's do return decode opcode group 4, 5. Then we want opcode L. And need do it up here then. Okay. So it actually needs to be this. Then I guess we don't need opcode L. All right. What do we say? All right, so this means we are in let's see. I'm just thinking about like what happens if we get into this area. We don't want to contribute. We don't want to falsely consider these call instructions and stuff. So let's do two different functions. This one just won't be implemented yet. So we'll say if could do an early exit. Otherwise, 2-byte instruction, I think, for all of these. So let's go back to deck. Okay. Then oh, and we do want the low. Or, oh shit. Okay. No, I think I'm gonna get rid of this one. And what we're gonna do is say if the instruction extension code where are we at? Group 5 and 4. So if it's a 0, 0, 0 or 0, 0, 1, then we're good. Otherwise, we'll return 0, and eventually we will handle these and return 0 for this. Going to be explicit. I could obviously write 1 there, but just feels like the right way to go. Okay, so that sets the opcode. I'm always writing too few tests for what I want to be doing. So let's look at look at deck, but I'm going to write an inc instruction. So we can do a reg 8 and reg 32. As well as mem with a let's do a sib displacement 32. Is there anything else we need? And then naming convention here is terrible, but yeah. Do the same for deck. Or you know what? I'm going to delete those and we'll just write the tests first. So these are going to be single entry tests or multiple. Just going to do single. All right, so the encoding is going to be F, and what W bit is off on this one. So FE for the opcode, and then we'll have C and what do we want to pick for the register? 11 011, so it'll be 1011, which is B. Okay, and there, it's just a 2-byte. FECB should be inc. Instruction size is 2. It's going to be a register operand. So we can do that. No, I like that. Okay. But this is just going to be OT none. So it's a register with the register being 011 is B. So it'll be an inc EBX, or because it is an 8-bit, it's going to be inc BL, or dec BL rather. Okay, so I need to switch this to FF, yeah, because I'm looking at, no, wait a second. Need to switch this to be 00 011, so it's going to be just 3. Yeah, so that'll be an inc BL. Then we're going to do a 32-bit, so this will be an F, and let's do 10. Let's do 2. That'll make it EDX. So this will be inc EDX. Yeah. And then we're doing an 8-bit version. So go back to FE, and what we need is a mod. We have a SIB with displacement 32. So I don't remember off the top of my head what that looks like. And SIB with displacement 32 is a 100. And then it was 0, 0, 0, so it's just going to be 8. And then or sorry, no, the mod is 10. And then 0, 0, 0. So yeah, it's still 8. But the RM is 0, 1, 0, 0. So 8, 4. And then we've got an SIB, which is, let's pick one. ESI times 4. So we're going to do 1, 0. ESI times 4 plus EDX. So we can just do B2. And then we have a displacement that's 32 bytes. So we can do 1F. Okay. So the instruction size should be 7. The register for operand 1, it's actually a mod RM. And no, it's an SIB. So the base, or how do I do it up here? What order do I do it in? I do scale, index, and base, so I just keep with that form. Okay. Then scale is gonna be 4. So register for the index is ESI and EDX for the base. I feel like this is not going to be able to correctly take into account that we have set the W bit off. So it's going to increment it as a byte pointer, but I don't think I have anything in the instruction output that represents that it's a byte pointer. So let's see what it looks like with Zydus. FE84B21F 000000. So yeah, it's an inc byte pointer of EDX plus ESI times 4 plus 1F. Okay, so I have all that stuff, but we still really need a size piece on there. And I don't think I'm going to get to it on this stream just because I'm going to have to go back and update all the other instructions that I have to include include that information, but there's just no way to look at this set of instruction data and recognize that the operand 1 is referencing a single byte in memory, which is my bad. And we probably need that on mod RM as well. Whereas I think for the immediate and obviously for the register one, we can determine the size. We can determine the size for the register just based on what register it is. And for the immediate, it's either like we're going to do all the conversion, so we can just treat it as a 32-bit value after the fact, even though it might have been encoded as 8 bits or 32 bits originally. But there's not really much point to having the concept of a size of an immediate. So we will be adding the size just to the mod RM and the SIB operand structures, but we'll do that on the next stream. So throw this in, and we want FF now, and then an SIB with displacement 8 is going to be let's see, I don't know, we could do 54. Does that matter? Oh yeah, because it's not going to be, so we just need to calculate it ourselves. So it's going to be 0, 1, 0, 0, 0. So 4, and then just 44. Okay, and then what? We can do this one, D0. It's going to be EAX plus EDX times 8. And we'll just have 1 byte for the displacement. So I said it was EDX times 8 and EAX was the base. Okay, and then the scale is 8. And the size on this one, just 4. FF44D02F should be inc dword pointer EAX plus EDX times 8 plus 2F. Inc dword pointer EAX plus EDX times 8 plus 2F. Okay, cool. So we have those set of tests, and I'm just going to copy these. And for right now, we're going to do the same things, but change all of inc to dec. Okay, and then we need to fix the instruction operands, or the bytes rather. So it's still going to be FE, but we're going to have 0, 0, 1. So we're going to have 8 plus this. going to be B, A, and C. That makes it a deck. So let's see, we changed that 4 to a C. Now it's a deck version. Okay, cool. So these should pretty much fail. Okay. Let's see. How far am I gonna get with these? We want to still send the flags. I think we do need to send the flags. Okay. So that's how we get the opcode, and then so we can just do mod rm and swap the registers, swap the operands rather, because our mod rm is going to put it in operand 1 and operand, or in operand 2 it's going to put the one thing. So this is where it puts operand 1 stuff. Okay. That seems fine. It's going to be and want to reduce that scope. What is this still? Oh, okay. Oh shit, they all passed now. Okay, cool. So now we are decoding all forms of increment and decrement. Perfect. I am feeling okay about that. Then yeah, I think I'm gonna end the stream here. 3 hours is about how long I usually go. I don't know if you ever made it back, Linus didn't make Linux, but again, I want to say thanks for coming in, chatting with me, and for everybody else that was watching the stream and chatting, or just, you know, watching silently, whatever. And if you're watching this on the VOD, thanks as well. I will be back tomorrow, switching back to working on hacking practice. Gonna keep going through the Nightmare course and work on the ROP series of challenges. We've been making decent progress through those, and I'm sort of getting back in the habit of writing ROP chains and stuff, so we'll just keep that up. And then Thursday, go back to continuing on with this. I don't know what I'll be doing for the next chunk in this one. I at least one part will be setting those operand sizes on the modrm and SIB types, so that we can check that we know what the correct types are for those things. Oh, and I need to fix the type here, so I'm gonna real quick this is still just, we could put it, yeah, whatever. Okay, still works, yeah. So that's what I'll be doing tomorrow and Thursday, and Friday more hacking stuff, and then Saturday, Sunday back to Try Hack Me, which has been, I don't know, a mix of good and frustrating, primarily because of the networking issues. So we'll see if I end up spending some time getting that fixed. But this is the end of this stream. Have a good one. See you tomorrow.
I can feel them, I can feel them, I can feel them. Do well. I can feel them, I can feel them, I can feel them.